One way to solve a quadratic is the quadratic formula. And the formula is here to the left, which states x equals the opposite of b plus or minus the square root of the quantity b squared minus 4ac, and that's all divided by 2a. Make sure when you do your formula that you make your fraction all the way across. That whole thing on top, the numerator, is divided by the 2a. I was shared a song years ago. It's sung to Pop Goes the Weasel. I'll sing it with you. It does help you remember the quadratic formula. It will haunt you probably for the rest of your life. And it goes, x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So you can practice singing it as you write it, which I like to do. So let's do it one more time. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So you can sing it and practice writing the formula to help you learn it. On our first example, we are solving a quadratic formula, which is in the form ax squared plus bx plus c equals y, but in this case, y is going to equal 0. The quadratic formula is giving you your solutions or x-intercepts. It's when y is 0. So our a for this problem is 1, b is 3, and c is equal to negative 10. So I'm going to plug that in my formula. So x equals the opposite of b, so 3 is b, so the opposite of that is negative 3, plus or minus the square root, and I automatically square b. And when you square b, you'll get a positive number. If b is positive, it's positive when you square it. When b is negative, when you square it, you get a positive. So I always like to make sure that I square it. That first value underneath the square root b squared better be positive. Then minus 4, a is 1, c is negative 10. And that whole thing is divided by 2 times a. So this will be negative 3 plus or minus the square root. And this will be 9 minus 4 times 1 times negative 10. And if you simplify that, that just gives you 49. You can type that on your calculator. Over 2. And 49 is a perfect square. So this will be negative 3 plus or minus 7 over 2, which means I'll have 2 solutions. My first one is negative 3 plus 7 over 2. So that's 4 over 2, which is 2. My second solution is negative 3 minus 7 over 2, which is negative 10 over 2, which gives me negative 5. Note, on this problem, I could have factored that. It would have to multiply to negative 10 and add to 3. The numbers that do that are 5 and negative 2. So if I were to factor this, this would be x plus 5, x minus 2. So my solutions then would have been negative 5 and positive 2. Factoring is faster than the quadratic formula. The quadratic formula always works, though. And we'll be talking in a later lesson about when to use which model. On the next one, I have r squared minus 6r equals negative 4. So you have to set it equal to 0. So r squared minus 6r. I'm going to go ahead and add 4 to both sides. And in this case, what's in front of the r squared is 1. So a is 1. B is negative 6. And c is 4. And this time we're not solving for x, we're solving for r. So we'll have r equals the opposite of b. This time b is negative, so this will be opposite of b, which is 6, plus or minus the square root. When you square -6, you get positive 36. Then it's -4 times A times C, all over 2 times 1. This is 6 plus or minus. Go ahead and do 36 minus 4 times 1 times 4. That'll give you 20. And that's over 2. Now 20 is not a perfect square, so we'll go ahead and round this. You'll want to do 6 plus the square root of 20 in parentheses, and then divide that by 2. When you do that on your calculator, you'll get approximately 5.24. And on the second one, you'll do 6 minus the square root of 20. Make sure you put that in parentheses, divided by 2. And that is approximately 0.76. On example 3. This time, our A value is not 1. A is 10. B is -13. And C is -3. So we have X equals the opposite of B. So opposite of -13 is positive 13. Plus or minus the square root. When you square B, -13 times -13 is positive. This first number here always should be positive. That's a mistake I say a lot of people do. That's why I said go ahead and just square B, make sure that that's positive. So that's B squared minus 4 times A, which is 10, times C, which is -3. And that whole thing is divided by 2 times A. So this becomes 13 plus or minus the square root. And if you simplify it, 169 minus 4 times 10 times -3, that gives you 289. And that is divided by 20. 289 is a perfect square. So this is 13 plus or minus 17 all over 20. So you get two solutions, 13 plus 17 over 20. Make sure you put that in parentheses. So that's 30 over 20, which is 3/2 or 1.5 if you want to write it as a decimal. And the second one is 13 minus 17 over 20. And that's -4 over 20. So -1/5, or if you want to write that as a decimal, -0.2. Example 4. A is 1, B is -5, and C is 7. If these are not written with your squared term first, then your linear term, and then your constant, make sure that you write it in standard form. You need to have your highest exponent to your lowest exponent. Solving for this, in this case we don't have X, we have D, so D equals the opposite of B, so opposite of -5 is +5, plus or minus the square root. Notice I have -5 here, so I need to square -5. When I do that, I get +25. That first number has to be positive. -4 times A times C, all over 2 times A. And then I get 5 plus or minus, and when I simplify that, I get square root of -3. Square root of 3, there is no real solution for. You cannot take the square root of a negative and get a real number. So on this answer now, there are no real solutions. in later classes, you'll have imaginary solutions, but for this class, we are just working with real solutions. So there are no real solutions for this problem. So that's what you'll just need to state if you get a problem like that. For example 5. In this case, your squared term is p squared, so it is a quadratic. The value in front of it, your coefficient, is 1. There is no p term, so b is 0 in this case. And c is negative 25. This is a difference of squares and would factor much quicker than using the quadratic formula. However, this lesson's on quadratic formula, so that's what we're going to use. So p equals the opposite of b, so negative 0, plus or minus the square root of 0 squared minus 4 times a times c, all over 2 times 1. So then negative 0 is the same thing as 0, so that just goes away. You'll have plus or minus the square root. And if I simplify this, this is 100 in there. And that is all over 2. So this is plus or minus 10 over 2. And so I get two solutions. My first one is 10 over 2, which is 5. My second one is negative 10 over 2, which is negative 5. Last example. Notice these are all divisible by 2, and I've got it set equal to 0, so I can divide both sides by 2. You cannot divide by a letter, but you can divide by a number. So on this one, divide everything by 2, and you have g squared plus 6g plus 9 equals 0. And you could use a is 2, b is 12, c is 18. You're just going to have larger numbers when you use the quadratic formula. And I'm lazy. I'd rather use smaller numbers and larger ones. So a is 1 in this case then. B is 6. C is 9. And so g equals the opposite of b plus or minus the square root of b squared minus 4 times a times c. So fill those in, divided by 2 times a. So this will be negative 6 plus or minus the square root. When you simplify that, you get 0. So this is going to be negative 6 plus or minus 0 over 2. Negative 6 plus 0 over 2 is going to give you negative 6 over 2, which is negative 3. And then on the second one, negative 6 minus 0 will also give you negative 6 over 2, which is negative 3. So you get the same answer on both of those, which this was a perfect square trinomial. It would have factored into g plus 3g plus 3, which would have given you those solutions. Factoring is faster than the quadratic formula if stuff factors. But again, today's lesson was on the quadratic formula, so that's how I solved everything. We are done for the notes.